So I will write 40 times 39 times 38, and I'll stop at 38. 4, I know it's 4 times 3 times 2 times 1, but there is no point in writing the 1 because it's in a product. And I will simplify 40 by 4 by 4, and 3 and 39 and 2 and 5, 65.
You can totally do that with anything. You can just keep simplifying like you did, no problem.
Oh yeah, yeah. Yeah.
On number 15, it says solve the system of nonlinear inequalities. And the inequalities are 2x minus y is less than 6, and x squared plus y squared is less than or equal to 9.
Perfect. So the first one obviously is a line, and remember the steps are as follows. 2x minus 1 equals 6. And we have to find 2 points. When x is 0, I covered it. Y equals negative 6. So 0, negative 6. I covered now y. When y is 0, x is 3. So 3 comma 0. I did this fast because we all know by now how to graph linear functions. We shouldn't even talk about it. But of course I will go back and explain again if there is any question. 0, negative 6, and 3 comma 0. It is not a solid line. I write on it 2x minus y equals 6. I did not graph the inequality yet. I will graph now the inequality. I'm going to check this area because I like to pick 0, 0. 0, 0? Yes, that's true. It is a number less than 6. So therefore, I will shade in, and this is 2x minus y less than 6. Everything except points on the line. Then I continue with the second one, which is x squared plus y squared equals 9. Okay, what is this?
The equation of a circle.
Excellent. Centered where?
0, 0.
Excellent. And the radius?
3.
Yes. Solid? Solid or not?
Solid.
Good. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Uh, 0, 0 because I'm checking the inside. That's correct. And now I have, sorry, I rushed. This is x squared plus y squared equals 9, but everything inside is x squared plus y squared less than or equal to 9. Now I have to intersect blue and orange. Everything on the curve, on the circle, not on the line. And everything inside, and this will be both. Now here's what I would like to do. In y equals, I want to see this graph, and let's do this. 2x minus y equals 6. I have to solve for y. I cannot put this in the graphing calculator. I have no choice. So I'll move y and move 6. 2x minus 6 equals y. So first equation will be y equals 2x minus 6. There is a way of putting this in, and I'll show you how, but for now, let's solve for y squared. Negative x squared plus 9. We know that the circle is or is not a function. Is the circle a function or not?
Yes.
By the vertical line test.
It's not.
It's not. It's two functions. What do you mean? It's this, one function, and it's this, the second function. So when I take the square root, remember, what do I have to put in front when I take the square root?
Minus.
Yeah, that's why we have two functions. So let's put all these in the graphing calculator. This is function 1. And this is function 1 with a plus, and function 3 actually, y1, y2, and y3, the other one with minus. Let's do that. And I'll tell you why I'm doing this in a moment. So, 2x minus 6, 2x minus 6 as the first function. Positive, we don't have to put the positive, just the square root. You know me, I'm in love with my parentheses. So minus x squared, this minus right here, we start with this minus x squared plus 9, close the parenthesis. And the second function identical, but minus outside of the square root. Minus this minus, the starting minus, the negative sign, the square root, again parentheses, it may work without, but you know me already, negative x squared, and then plus 9, the same thing. One with positive in front, one with negative, but the same thing. And now, let's see, what are we interested to see? Not more than negative 3, 3, positive 3, 3, but I don't want just the edges, right? So I'm going to say negative 6 to positive 6, negative 6 to positive 6. Window. Negative 6 to positive 6 with a scale of 1. Then negative 6 to positive 6, even 5 it would be enough, but that's okay, with a scale of 1. And now let's graph. That's the line, that's the top part, and that's the lower part. Here is why I wanted to see it. To make sure that I was correct, that this piece overlaps or goes to the right of the line. What if the graph, and I was wrong, what if the graph would have done this? Which was impossible, but I just wanted to make sure. What if it were like this? I don't know, right? Well, my graph was not that off, but I just wanted to show and make sure that I'm correct. It is a little piece, as you see, that goes to the right hand side of the line. Just to check, just to show you how to put the circle in. There is another option for the circle with Conics, and I don't know, let me see where the Conics are. Applications, Don't do anything, just, yes, it is an application. So let's do this. APPS. So let's click on APPS. And go down to Conics. I know we haven't talked about Conics, but there are 4 Conics, and the circle is one of them. So scroll down or just pick 4. And you see circle, ellipse, hyperbola, parabola. We haven't talked about any of those other than the circle. So press on the circle, yes. And it gives us 2 types of equations that we've seen. One that has the perfect square completed, that's what we have, and the other one that does not. So we choose the first one. Okay, so H and K are the coordinates of the center. What coordinates does the center have? In our case?
0.
Yes. So put 0, enter, 0, enter. And what is the radius of our circle? That's it. Put 3 in and just hit graph. Here it is. Any questions? So that's another option of graphing the circle. So in applications and we have 4 different conics. They're called conics. And we only talked about the circle. In other classes, we talk about the other 3. Very good question. Thank you for asking that.
I think I'm doing this right, but just to double check, number 18 says find the sum after you write out all terms, and it's the summation notation with I equals 1 and then 5 on top. And
we say from I equals 1 through 5.
And then in parentheses, it's 2 times I to the second minus 3.
Perfect. So we have from 1 to 5, so if you want to write it out, you can. 2 times 1 squared minus 3 plus 2 times 2 squared minus 3 plus dot 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 plus 2 times 5 squared minus 3. And yes, you can, of course, do it by hand. However, here it is. We go to math. Scroll up to summation 0, press 0. We don't have j, I, k, so we have x, and goes from 1, and the top value, the upper limit is 5. In parentheses, I prefer putting another set. It may work without it, sometimes it does, sometimes it doesn't, so I don't want to mess with that. And then minus 3, and close the parentheses. So 2x squared minus 3, and when I hit enter, I should get the answer, 95. Very good.
The last one I had a question was question 8. Choose the relevant information from the following to graph one function, and the function is f of x equals 2x minus 4 over x squared minus 3x plus 2. And I think it wants the domain, range, x and y intercepts.
Sure. Yes. Fill out the chart. Yes. Yep. Everything. So, of course, when you give me this problem, I realize that it's type 2. Lower degree in the numerator than the denominator. I know that I have to immediately factor it out to the most. Do not attempt to simplify before you write the domain. And the domain obviously cannot be 1, cannot be 2. It cannot be 1, it cannot be 2. Now you can simplify, and you have 2 over x minus 1, that's the simplified form. As we remember, the factor that goes away is a hole in the graph. The factor that stays that I can't get rid of is a VA. Knowing that it's type 2, I know this. Definitely. When I plug in 0, I get negative 2. When I plug in 2, 2 minus 1 is 1, 2 over 1 is 2. It's a hole. I cannot have infinities. It's a hole. When I plug in 1, I know I have infinities, but I don't know the sign. On this side, I plug in 0.9. I do not put this in the table. I'm not going to graph. This is my check. 0.9, this is negative, so it's negative. 1.1, the whole thing is positive. I'm going to write not symmetric. How can it be symmetric with a vertical line, a vertical asymptote at 1 with a hole at 2? Cannot be symmetric in any way. That's all I need. I start by graphing the asymptotes. This one is redundant, but I'm going to present it no matter what. Is redundant because it's already there. One is very clear, VA, and the whole is 2, comma 2. 2, comma 2. And now 0, comma negative 2. And I'm ready. From approaching 0, crossing at 0, negative 2, going to negative infinity. From approaching 0, crossing at 0, negative 2, approaching negative infinity. From approaching infinity, crossing, going through 2, comma 2, going to 0. From approaching infinity, going through this hole and approaching 0. And this is the graph of f of x, 2x minus 4 over x squared minus 3x plus 2.
And last one is 10. Does the following equation represent a